Here is our AP Calculus BC, it's question 5. Let's do this together. Consider the family of the function fx is this one, where k is a constant. Find the value of k for k bigger than 0, such as slope of the line tangent to the graph fx equal to 0 is equal to 6. This means the line tangent, the tangent is equal to 6. Means the slope when x equal to 0 is 6. Or else we can see that f derivative of the fx when it's 0, this will equal to 6. So we need to derivative this one to find the derivative of fx. So the derivative of fx. So we know the rule of the quotient rule of derivation. So that's derivative, the numerator knows the denominator, so this will be 0 and 0 and minus derivative this part, note this part, multiplied together will be 2x minus 2 bracelet, and this part, and the numerator square and the denominator square, x squared minus 2x plus k squared, so this part. And then we make this thing a little bit different. Yeah, so write it as this one and equal to, because I want to put this 0 outside. So we can write it as a negative and delete this one. This is a positive, and put it left side a little bit. Okay, so write like this. Then we substitute our f of 0, f derivative of 0, so will equal to the 0, put it in, so this will be a 2 divided by 0 a k square, and we know this equal to 6. We will see that the 2 divided by a k square, 2 divided by a k square is equal to 6. And we will see the k square is equal to 1 over 3. So I will see the k is equal to positive 3, the square root of 3 over 3, or the k equal to negative square root of over 3, negative. But we know that it's for k bigger than 0, so this thing we eliminate it because for k bigger than 0, yeah, so k equal to 3, the square root of 3 over 3. Yeah, that's much, not much. This is the first question. Okay, let's continue for the question B. For k equal to negative 8, find the value of integral 0 to 1 fx of dx. Let's do this together. So we have the integral in here. Let me change the color. So integral 1 to 0 fx when k is equal to negative 8. So this will equal to the 1 over x squared minus 2x minus 8 of dx. Then we change it into, then we try to factor this and try to use the partial integration. Integral and x minus 4 plus multiply with x plus 2. And this 1 dx. Then we change the color to find our x minus 4 and x plus 2. So they're together, this a together is 1. So I set a multiplied with x minus 4 plus a b is x plus 2 is equal to 1. So we find the ax minus 4a plus a bx plus a 2b equal to 1. That means ax plus bx is equal to 0. That means ax plus bx is equal to 0. That means a plus b is equal to 0. And negative 4a plus 2b is 1 because there's no x in here. So this two constant term a together need to be 1. So negative 4a plus 2b equal to 1. So we need to solve the system of equations. So this is a linear algebra thing. We make the 4 multiply with both sides of the first equation. We got a 4a plus 4b equal to 0. And the a together, we got 6b. And we add this 6b equal to 1. And we got b is equal to 1 over 6. So a equal to, because a plus b is equal to 0, so they must be the negating of the b. So negative 1 over 6. So we need to rewrite the part, this part. When we rewrite this part, we can rewrite this thing as a x minus 4 multiply with x plus 2. And join this two things together. There's a negative 1 over 6 of x minus 4 plus a 1 over 6 of x plus 2. Because this two things add together is 1. So we can separate this two part of this 1 of so this part is x plus 2, this x plus minus 4, this eliminate each other. So negative 1 over 6 plus x minus 4, because this x plus 2 eliminate each other. We got a positive 1 over 6 of dx. So we continue integrate this. We can make this into a line of negative 1 over 6 first, a line of absolute value of x plus 2 plus 1 over 6 line absolute value x minus 4, and we have this x equal to 1 and x equal to 0. Then we substitute in, we have negative 1 over 6, substitute 1 is a line of 3, and substitute 1 is plus 1 over 6 line of 3, because 1 minus 4 is negative 3, and absolute value of negative 3 is positive 3, and minus put a 0 into there, so we have negative 1 over 6 line 2, and plus 1 over 6 line. So this will be 4, right? Line that's 0 minus 4. That's a negative 4, and the absolute value. Yeah. So in here is a negative 1 over 6 line 3, and plus a positive 1. So they eliminate each other. Yeah. So the minus this one, we can write it as plus a line 2, and minus 1 over 6 of line 4. Yeah, line 4. And so here we can rewrite this thing. We rewrite this thing as 1 over 6 of line 2, because this 4 is the power of 2. The power of 2. The 2 power of 2. That's 2 squared. So we can write this. So let's take it out. It's 2 over 6 line 2. This two things can minus. We got a negative 1 over 6 line 2. Okay, so this is the answer. This is the answer. We integral. By the definite integral of this part. This is the answer. Okay, see you next question. Okay, let's solve question C. For k equal to 1, find the value of the integral from 0 to 2 f(x) of dx, or show that it diverges. Let's check. So for 0 to 2 f of x, that will equal to x squared minus 2x plus 1 over this much of dx. And if we do a little bit of the algebra in here, this would be x minus 1 squared over 1 over this thing of dx. Else we can check this kind of the graph. This graph basically looks like this. learn a little bit algebra, so we know that x cannot equal to, the x cannot equal to 1, right? The x cannot equal to 1. So the 1 will be, if we think this is 1, this will be a asymptote. Yeah, it's a vertical asymptote. It's basically like this. So, but it's asking to us to find from the integral of the 0 to 2. So this from 0 to 2, I think here. So this thing will be this kind of area plus this kind of area, So these two areas A together, this may diverge. We will see this may diverge, but we don't know. We need to find the integral, then we see it. So we can use this kind of thing, like we separate it from the 0 to 1, x minus 1 square, 1 dx plus from the 1 to 2, the x minus 1 square of 1 of dx. So we just change it to two part, this part, and from 0 to 1, then 1 to 2, this two part. Then because this never reach to 1, it can never reach to 1 because the x cannot equal to 1. So we need to change it into a limitation of integration as when the, let me use a, when the a approach 1, of the integration, let us just to get our integration first. So this is x minus 1 of negative 2 power of negative 2 of the dx integral. So I got to find the indefinite integral of this thing. So we can use the u substitution. So because in u substitution we can use a u equal to x minus 1, so we have the du equal to dx. So basically we have the u of negative 2 du equal to du, and the integral will equal to the reverse power rule. That's negative of u negative power of 1 plus c, and we substitute our u back, and x plus 1, so negative, and x minus 1 over x minus 1, yeah, and plus a c. Let's see. So this part of the integral, the indefinite integral. But this in here is a definite integral. So when a approach 1, that means that when the limitation like integral from 0 to a, but you can approach to a but never reach it. So minus 1 square of dx plus a limitation of a approach 1, but this is a to 2 of x minus 1 square of dx. So because we have already found our indefinite integral in here, so we can find our integral. That's put it in. So that's we will have a limitation as a approach 1 of negative x minus 1 or 1 over x minus 1 of a to 0, yeah, plus a limitation of a approach to 1 of negative 1 over x minus 1 of the 2 to a. Then we substitute in, we just directly substituting, we have the negative, then we have the limitation of the a approach 1 of the negative a minus 1 over a minus 1 the minus substitute in 0, the minus 0 inside, this will be -1, -1 over 1, so this negative, that will be positive, so it's a -1. So basically inside is like this one, limitation of this one, and also plus a limitation of approach 1, so we have substitute into 2. So we have the 2 minus 1, so as a 1, so that we have -1. So 2 substituting, this 2 minus 1 is a 1, and -1 minus substituting in A, so that's a plus a minus 1, yeah, so the same. So we can see, because when the A approach to 1, so A approach to 1, we can see this A minus 1, this A minus 1 thing, this A approach 1 from the positive side, let's check, because this from the left side, there's A approach 1 from the negative side, so we put a negative side here. And because this part is from the this side to the from, let me change a color for the left part, and the right part. Let me use this thing, to change a color for all of this part. Okay, I think it will work. So I will give a green. For this part, because that's a part that will approach one from negative side, so we will give a negative in here. And also we can see this part I think it's approach one from the positive part, so we will give them a red one, yeah. So this so give that red one. So this part is a approach to 1 from the positive part, is the 1 to 2, 1 to 2, the 2 to 1, this part. So we will give this a positive sign, So this part is because it's approach 1 from the negative side, and we can see, so we can put a negative 0.9 into here, so negative 0.9 in here, and the -1, so maybe 0.99, that's a -1, so we will see this part 0.9 into here, and 0.999 into here is the 2 to 1, so this thing will be very small, the A minus 1 from the left side. A minus 1 will be very, very small, like 0.9 minus 1. This is a negative 0.1, right? So this will be go to infinitely the infinity negative side, yeah, to the very big. So this thing goes very big from the left side in the negative way. So A minus 1 of this part, this will be very big. To approach from the left side, you can imagine this 0.9999 into there, so there will be a very big negative thing, and you also negating it, so there will be a positive infinity minus 1. So this thing will be very, very big. This thing will be a very big one. And also is a approach from the positive part. This from the positive part, the A minus 1 will still go into a very, very small, like 1.1, 1.0001. So this will be a positively. So A1 over A minus 1, this will be pretty big, and it's a +1. So this thing will go to a unlimited part. So will go to diverge. So this because the A minus 1 over A minus 1 is it will grow bigger and bigger. So this part will diverge, and also we can check this in our graph. So the integral of 0 to 2 f of x of dx goes to diverge. Will diverges like this. So this is what we do with the question C. That's all of the question 5. See you next time.